triangles are a little bit complicated. There are lots of segments that we can define inside a triangle, like perpendicular bisectors and angle bisectors and medians. And then there are actually a lot of different ways to think about what the center of a triangle is. One of them we're going to talk about today is the circumcenter. These all have fancy names, these different centers for triangles. The circumcenter happens when you draw in the perpendicular bisectors. If you put in the perpendicular bisector of each side of a triangle, they always cross at a single point. That single point is called the circumcenter. And it has an interesting property. That property is that it's equidistant. It's the same distance from each of the three vertices. So if you measured these lines from A to the center, B to the center, C to the center, they would all be exactly the same length. And it's this property of a circumcenter that we're going to need to know to solve the problem. Let's take a look at the problem we've got here. So we've got this complex diagram down here. What you can notice is there are perpendicular bisectors in here already. So these guys are perpendicular bisectors. That means this point S in the middle has to be the circumcenter. They've also drawn in lines from each of the vertices to the center. So what that means, since this is the circumcenter, is that each one of these lines is going to be the same. We've also got perpendicular bisectors here, so each side of these is going to be the same. Actually, not the same as the other line, so let me put different hash marks on them. Okay, so that is all the information I know from what we've got so far. Let's read the problem here. It says that the perpendicular bisectors are TS, US, and VS. Those are the ones we marked in pink there. They meet at point S, which is the circumcenter. And then it says VS is 66. So VS is this one, 66. We'll put that in. It says YU is 86. That's this one. And it says ZS is 110. That's nice. So we have the distance from a vertex to the circumcenter is 110. That's great. So I know this is 110, and I know this is 110 as well. Okay, let's see what they're asking for here. We want to find XS, YZ, and VY. So XS is actually this line right here from X to the center, and I just filled it in as 110. It's got to be the same as ZS. So XS is 110. All right, let's work on YZ. So YZ is this whole side right here. Because these are perpendicular bisectors, we actually have half of it. So this other half is 86 as well. So YZ is just 86 plus 86, which is 172. All right, and last we need to find VY. That's this side right here. And one of the things I can see is that I've got a right triangle here. Actually, let me just outline that in a different color. So that's the side we're trying to find. And then these two other sides make a right triangle, and I have the measurements for those sides. So I could use the Pythagorean theorem, a squared plus b squared equals c squared. The hypotenuse here is the 110 side. So the c squared is 110 squared. B squared we can put in as 66 squared, and then we'll solve for a squared. Well, we'll solve for a. So let me pull out my calculator. 66 squared is 4,356. So I've got a squared plus 4356 equals 110 squared, which is 12,100. So to solve for a squared, I need to subtract 4356. So I get a squared equals 7744. And then to solve for a, I need to take the square root. So we'll do that. And I get, oh, it's an even number. I get a equals 88. So Vy is 88. So that is how to use the circumcenter to find some segment lengths in triangles.